We're going to practice using these new derivative rules with some old types of problems that we've seen. So first we're going to find f prime of x and the equation of the tangent line at x equals 0. So we've found derivatives and we found equations of tangent lines. The only new thing we're going to be adding in here is that we're going to be using either our product rule or quotient rule. So we have, for our function, f of x equals x squared minus 4x plus 2 times e to the x power. Now, one thing I'll mention, this is going to be a product rule, and I'll mention that because I think sometimes when we're first starting off, when we're very first learning the product rule, it can be difficult to recognize when do we need to use the product rule and when do we not. What I might recommend doing is anytime you see parentheses, or if you see, something like 4x times e to the x, I might recommend rewriting the problem so that it has the multiplication symbol in there, so that you see 4x times e to the x. So if I was going to do that for this problem, it would look like f of x equals x squared minus 4x plus 2 times e to the x power. And I think when you write that out, when you write out that multiplication symbol, it becomes a little bit easier to recognize, oh, this is going to be a product rule problem. Because when I set up my product rule, I'm going to say, okay, here is my f of x, and here is my g of x. So we have our f of x and we have our g of x. Let's find our derivative now. And just so that we have the product rule on hand, f prime of x is equal to, I know the product rule says f prime times g plus f times g prime. So I'm going to start off with f prime. What does the derivative of f look like? So I want the derivative of x squared minus 4x plus 2. So the derivative of that piece would be 2x minus 4. There's my f prime. Next up, I have times g, so times just e to the x. I don't need to do anything with that piece. It'll still just be e to the x. Plus, what do we have next? Next we have f. So I'm going to take this exact function, not its derivative, its exact function. So we'll take times x squared minus 4x plus 2. And then for our last part, times g prime. So I want the derivative of e to the x. And again, the derivative of e to the x is just e to the x. If you're feeling like this is moving a little bit too fast, then I might recommend for your first few problems for your product rule, use that method that we talked about when we very first started talking about the product rule. Say, okay, here's what f is, here's what f prime is, here's what g is, here's what g prime is. I think that can be really, really helpful in applying your product rule. So this is our derivative using the product rule, but it's not particularly, it doesn't really look nice. I think we can simplify this. There's a few different ways we can do this. If you'd like, you can distribute that e to the x to all of your terms. I think that's probably what most of us would instinctively do, so I'm going to do that. So we'd have 2x times e to the x minus 4 times e to the x plus x squared times e to the x minus 4x times e to the x plus 2 times e to the x. And now I might look at this and say, well, all of these terms have a factor of e to the x. Every single one of them. I could just factor that e to the x out from every single one of my terms. It would make it look a whole lot nicer. So that's what I'm going to do in my next step. E to the x, and that will leave me with 2x minus 4 plus x squared minus 4x plus 2. And I actually could have done that back here. I actually could have factored out e to the x in this step if I wanted to, but that's okay. We got there. The only thing left for me to do at this point is to combine my like terms inside of those parentheses. That would give me e to the x times x squared. Let's see, 2x minus 4, that would be minus 2x, and then negative 4 plus 2, that would be minus 2. So this is my derivative f prime of x. So there is the first part of my answer. So the product rule we've seen, we've done that a couple times now. The new part, or rather the old part then, is to write the equation of the tangent line at x equals 0. So remember, for the equation of the tangent line, I need three things. I need an x value, which that will always be given to you. I need a y value, and I need a slope. To find the y value, I'm going to look at my original function, f of x. So to find the y value, I'm going to plug x equals 0 into f of x. So I'm actually just going to, really quickly here, I'm just going to copy this function down so that I have it in front of me. I don't make any silly mistakes. So here's my function f of x. And I want to plug in, we said that the point that was given to us was x equals 0. So I'm going to plug 0 into this function. So y is equal to f of 0. This is equal to 0 squared minus 4 times 0 plus 2 times e to the 0 power. And we just need to simplify this part. So 0 squared, that's going to be 0. 4 times 0 is 0 plus 2. E to the 0 power, anything to the 0 power is always going to be 1. So I'm left with 2 times 1, which just simplifies to be 2. So that means my y value is 2. So there is the first part. I need the y value. The second part I need then is the slope. And I remember that the slope of the tangent line is always given by the derivative. So I'm going to take the x value that was given to me and plug that into my derivative. So my next step, we'll say f prime of 0 is equal to e to the 0 power times 0 squared minus 2 times 0 minus 2. And again, I'm just going to simplify this as much as I can. We said anything to the 0 power is 1 times 0 minus 2 gives me 1 times negative 2, or just negative 2. There's my slope. So now I have my x value, I have my y value, and I have my slope. So at this point, I've got everything I need to write the equation of my line. So if I use point slope form, that'll look like y minus my y coordinate, we said that was 2, equals m, our slope was negative 2, times x minus my x coordinate is 0. And at this point, all we need to do is solve for y. So y minus 2 is equal to negative 2x, which means that we'll end up with y equals negative 2x plus 2 as the equation of the tangent line. So for these kind of older problems that we've revisited when we're talking about writing the equation of the tangent line, once you have the derivative, it's finding the derivative that's kind of a little bit new. It's using that product rule or that quotient rule. But once you find that derivative, the rest of the process is going to look very, very similar. You're going to find your y value by plugging that into your by plugging your x value into your original function. Find your slope by plugging your x value into the derivative, which you already found. And then to write the equation of the tangent line and to simplify that.